Welcome back. This is Exponents, Exponential Functions, the lecture part 2, and this time we're going to be looking at some transformations. This is a parent function, y equals 2 raised to the x power. X is in the variable is in the exponent, and remember the very basic shape of this thing is going to be, goes through 1 above the origin, shoots out to the sky, becomes an asymptote, or the x-axis is an asymptote off to the left. All right, what happens with this function? Well, this plus 3 is the very last operation on x. X has been is a power on 2, and the last operation is add 3. That will be a vertical shift. So here's the parent function right here, and here is the function raised up 3. This was the point of reference. This place right here is 0, 1, and up 3, that becomes 0, 4, because 1 plus 3 is 4. That's the coordinate where that thing now goes through. 4 above the origin, where this one was only 1 above the origin. What happens with this function? Well, this x minus 5, the minus 5 is grouped with the x in the exponent. That is the first operation on x. And just as we have studied exponential function or other kinds of functions, if the very first operation on x is a plus or a minus, then that is a left-right shift, and it's opposite from what you expect. So subtracting 5 means that that function, our parent function, this thing, is going to be moved to the right 5. So this is the parent function that goes through 0, 1, and this is the transformed function, translated 5 to the right. So this place, 5, 1, right there, is now on the graph. 5, 1, right 5, and it is still up 1. Now, one more function we're going to look at is 2 raised to the negative x power, and then and if you look at that, and I'm going to compare this one with well, it's actually the same function as 1/2 raised to the x power, because 2 raised to the negative x power is the same as 1 over 2 raised to the x power. So those two yield exactly the same function. Those are falling from left to right. We call those things exponential decay, whereas these functions, as this one, is an exponential increase, because they are rising from left to right. Let's look at one more thing. Let's see what happens when there's a negative out front. Remember, that's not a negative base. 2 is raised to a power, and then the whole thing is multiplied by a negative 1. So that negative 1 is really like a negative leading coefficient. So this is this function. Y equals negative 1 times 2, negative 1 times 2 raised to the x power. That's a negative leading coefficient, which should flip this graph over. And sure enough, here's our parent function, and here it is flipped across the x-axis. So that's a vertical flip. Some will say it is a flip across a horizontal line, or reflected across the x-axis. All of those would refer to that function. Let's talk about the domain and range of each one of these functions. So let's go back to that very first function, this one right here. And notice that for an exponential function, the variable is the exponent, and I said earlier that an exponent can be anything at all. It can be positive, it can be negative, it can be rational, it can be irrational. So that means, since x can be anything at all, that the domain of an exponential function is from negative infinity to infinity, But the range can depend, as you see that this thing never gets below the x-axis, or the parent function at least never gets below the x-axis. For this function right here, that function has been translated up 3. So the part that it never gets, the asymptote on this one would be a horizontal line 3 above the origin. The equation for that line is y is equal to 3. So what's the domain? Well, how low can I go and still find that function, any points on that function? So the range of this function, the translated function, is from 3 up to infinity. The lowest I can go is 3, but I can go as high as you want and still find graph. This is the function that has a left-right shift, and the left-right shift function is going to have the same domain as the parent function. This is the parent function. What's the domain on the parent function? The domain of the parent function, again, is from negative infinity to infinity, whereas the range is, how low can you go and still find function, is from 0, but not including 0. It's never going to get to 0, up to infinity. And if it's just moved left, right, then that range has not moved. For the exponential decrease functions, the range is again, or the domain is again, from negative infinity to infinity. This thing keeps going upward, but it also keeps moving to the left. And then out to the right, it keeps, that becomes an asymptote on the x-axis. It gets very close to the x-axis very quickly, which is why it looks like it ends, but it really doesn't. It really keeps on going, getting closer and closer to the x-axis. Half of a half of a half of a half is going to be very close to the x-axis. So the domain on this thing is from negative infinity to infinity. Why? Because an exponent can be absolutely anything. The range on this thing is from 0 up to infinity. And that's what we know about exponential functions and basic transformations.